In this video, I have discussed a few questions from sequences and series, and the questions in this video I have taken them from the miscellaneous exercise of Maharashtra Government Textbook 11th Standard Maths Part 2. Let's begin with the first question. It says that in a GP, the fourth term is 48, so you have T4 as 48. The fourth term means a into r power 4 minus 1, that is a into r power 3. Then they've said that the eighth term is 768. Eighth term means T8 is 768, and the eighth term can be written as a into r power 8 minus 1, that is a into r power 7. There are two unknowns a and r, so we can eliminate one unknown if we divide the two equations. Dividing equation 2 with 1 will give us r power 4 on the left and 768 upon 48 on the right hand side. So when you cancel off a 2 in the numerator and denominator, you get 384 and a 24 here. Then 2 into 192 and 2 into 12, and 12 will be multiplied by 16 to get 192. So r power 4 is going to be equal to 16. We take a fourth root on both the sides, and the value of r will now be plus or minus of 2. Just for easy calculations, I'll currently take it as plus 2 and go ahead. But you need to understand that every time you are attempting exams like JEE mains or MHT CET, or any of the competitive examinations, you need to consider both the possibilities. For the time being, let's put RS2 and go ahead with our calculations. If we put RS2 in either equation 1 or equation 2, put RS2, so 2 cube is going to be equal to 8. That 8 goes on the right hand side, and 48 upon 8 becomes equal to 6. So A will be equal to 6. And finally, they are asking us the value of the 10th term. So the 10th term means A into r power 10 minus 1, that is A into r power 9. A will be equal to 6, and r power 9 is 2 power 9, but 2 power 9 is 5 and 2. So 5 and 2 into 6, that will be, okay, you can say it is 1024 into 3, and 1024 into 3, that's going to be 3072. Yeah, so 3072 is the 10th term, and with that we go ahead with the next question. The sum of first 5 terms of a GP, whose first term is 1 and the common ratio is 2 by 3. So we straight away have to apply the formula. Sum of the first 5 terms will be given by, the formula is a into r power n minus 1 upon r minus 1. So it's like sum of the first n terms is given by this formula for a GP. So sum of the first 5 terms will be the first term a, which is equal to 1, the common ratio 2 by 3. Okay, so if the common ratio is lesser than 1, we write the formula in the reverse way. That is 1 minus r power n upon 1 minus r. So this will be 1 minus 2 by 3, the whole power 5, the whole divided by 1 minus r, which is 1 minus 2 by 3. So this becomes 1 into anything is the same number. In the denominator you have 1 by 3. That 1 by 3 can be written in the numerator as 3. And this becomes 1 minus 2 power 5, which will be 32, divided by 3 power 5, which is going to be 243. So if we subtract the two numbers, we have 243 minus 32, which is equal to 211, divided by 243. But that 243 will further be multiplied by, it's 3 into something upon 243. So 3 and 243 get cancelled, giving you 81. So the sum of the first 5 terms for the given GP is going to be 211 upon 81. Let's continue with sum number 3. So for a GP, they have said that the first term a is 4 by 3 and the 7th term is also given. So find the value of r. So T7 is written as ar power 7 minus 1, that is ar power 6. T7 243 upon 1024. And that should be equal to the that should be equal to the first term, which is 4 by 3, into the common ratio, which is r power 6. So if we take this 3 on the other side and 4 on the other side, you can write 243 actually as 3 power 5, and 1024 is like 2 power 10. But if you see a 4 here, it's very evident that instead of writing it as 2 power 10, it would be better if we write it as 2 square the whole power 5, that is 4 power 5. So this is how we are writing 243 upon 1024. And that 4 by 3 from the right, when it goes on the left hand side is going to become into 3 upon 4, and that will be r power 6. So we have r power 6 being written as 3 power 6 upon 4 power 6, which tells you that the value of r will either be plus or minus of 3 by 4. Just taking the positive term for now, r is being taken as 3 by 4, and yeah, that's how we are answering the third question. The fourth one, for a given sequence, the nth term is given to you. Verify whether the following sequence is a GP or not. If it is a GP, find the first term and the common ratio. So if you have the nth term, as 5 power n minus 2 upon 7 power n minus 3. Try finding the n plus 1th term. So Tn plus 1, all that you need to do is you have replaced n with n plus 1. N is replaced with n plus 1 on the left hand side. So on the right hand side also you will replace n with n plus 1. So this will be 5 power n plus 1 minus 2 divided by 7 power n plus 1 minus 3. So this becomes 5 power, it is n minus 1 upon 5 power n minus 2. Now take a ratio of the n plus 1 upon nth term, and you realize that this will be 5 power n minus 1 upon, sorry, this was a 7 power n minus 2 here. So 5 power n minus 1 upon 7 power n minus 2 divided by t power n means multiplied by the reciprocal of t power n. So multiply it with 7 power n minus 3 upon 5 power n minus 2. Now 5 power n minus 1 upon 5 power n minus 2. You can write it as 5 power n minus 1 minus n minus 2 and 7 power n minus 3 and 7 power n minus 2. So you can write in the denominator 7 power n minus 2 minus n minus 3. If you open up the bracket here, this becomes minus n plus 2. N minus n get cancelled. Minus 1 plus 2 makes it 1. So here you have 5 power 1 which is 5. Similarly, if you open up the bracket in the denominator, you will be left with 7 power 1 which is equal to 7. So now if you realize the ratio of any two consecutive terms is a constant, and that satisfies the definition of a GP. Because the ratio of any two consecutive terms is a constant, we said that this is a GP, and the ratio of any two consecutive terms itself is the common ratio of the GP. So the common ratio of the GP is 5 upon 7, and to get the first term, all you need to do is put n as 1 in this case. In this case means in that formula. So when you put n as 1, your first term becomes 5 power 1 minus 2 divided by 7 power 1 minus 3. That is 5 power minus 1 upon 7 power minus 2. 5 power minus 1 is 1 upon 5 in the denominator. This will be 1 upon 49 in the denominator. That 49 goes up and you have 49 in the numerator. So 49 upon 5 becomes the first term and the common ratio is 5 upon 7. That's how we are answering the fourth question, and with that we go ahead with the fifth one. Find three numbers in GP such that their sum is 35 and product is 1000. So every time you need to find three numbers in GP, you take them as A by R, A and AR. They are sum. Okay, first we'll go for their product. The product is 1000. So multiply the numbers. You have A by R into A into AR is equals to 1000. R gets cancelled and you have A cube as 1000. So the value of A becomes equal to 10. Okay. Now we apply the second condition that their sum is 35. So sum means A by R plus A plus AR. They have said this is equal to 35, but already we just got A as 10. So if A is 10, you can pull out a 5 common from all these three terms. So that will leave you with 2 by R, 2 and a 2 here. The 5 that you have taken common can be taken in the denominator here. So 35 divided by 5 becomes 7 on the right hand side. You can multiply throughout by R. So this will give you 2 plus 2R plus 2R square is equals to 7R. Take that 7R on the left. So you have 2R square minus 5R plus 2 is equal to 0. If you try to factorize this, it will be 2R square minus 4R minus R plus 2 equal to 0. So this is going to be 2R. From this bracket you are taking out a minus 1 common, and the leftover brackets are going to be 2R and minus, sorry, it's going to be R and minus 2. Okay, so either this bracket will be 0 or this bracket will be 0. If this bracket will be 0, we have R equals to half. If this bracket will be 0, we get R is equal to 2. Now whether you take R equal to half or R equal to 2, the numbers that you get are going to be one and the same. So if I take R as 2, the numbers are going to be A by R, which is 10 upon 2, that is 5, comma A, which is 10, comma AR, that is 10 into 2, which is equal to 20. Now if you take R as half and A as 10 and try to evaluate the numbers, then instead of getting 5, 10 and 20, you will get 20, 10 and 5, which are one and the same numbers only. So ultimately your required numbers are 5, 10 and 20. And yeah, that's how we are answering the fifth question. Going ahead with the sixth one, find 5 numbers in GP. So now that it's 5 numbers, we will take them as A by R square, A by R, A, AR and AR power 2 such that their product is 243. When you multiply all these numbers, the R terms are going to get cancelled and you are going to have A power 5 as 243, but 243 itself is 3 power 5. So the first term is equal to 3, that is A is equal to 3. The sum of the second and fourth number is 10. Second number is A by R and the fourth number is AR. So you have A by R plus AR is equal to 10, but we just got A as 3. So we have 3 plus 3R is equal to 10. Multiply throughout by R, so you have 3 plus 3R square equals to 10R, and that 10R also goes on the left. So on the right hand side you are left with a 0 and here you get a minus 10R. Try to factorize it, so you will have 3R square, then you will have minus 9R minus R plus 3 is equal to 0. So from the first bracket, from the first two terms, you can pull out a 3R common, and with that you will be left with R minus 3, and from here you can pull out a minus 1 common, and the final factorization will give you the two brackets here. If this is equal to 0, then R will be 1 upon 3, or if this is equal to 0, then R will be equal to 3. Again, in this case also, whether you take R as 1 by 3 or you take R as 3, the sequence of numbers that you will get will be the same only. So if you take R as 3 and A as 3, then the first number will be 3 upon 3 square, that is 3 upon 9, which is 1 by 3. The second number will be A by R, that is 3 upon 3, which is equal to 1. The next number is A, which is equal to 3. The next number is A into R, that is 3 into 3, which is 9. And finally the last number is 3 into 3 square, that is 9 into 3, which is 27. So these are your required numbers for the fifth question. Like I said, if you take R as 1 upon 3 and try to evaluate the numbers, you will get the reverse of this sequence. That is, the first number you will get it as 27, the second one is 9, 3, 1 and 1 upon 3. Ultimately, the two set of numbers that you get are the same only. So yeah, that's how we are answering the sixth question, and with that we go ahead with the seventh one. So you need to verify that the given sequence is a GP. You are given the value of Sn, that is sum of the first n terms of that given sequence, and every time you want to find the nth term is always found by the formula Sn minus Sn minus 1. Sn has been given as 4 into 7 power n minus 1 minus Sn minus 1. See, Sn is this. So if you want Sn minus 1, you replace n with n minus 1 on the left, and if you do that on the left, you replace n with n minus 1 on the right also. So Sn minus 1 will be 4, 7 power n minus 1 minus 1. Try to expand the bracket. This will be 4 into 7 power n minus 4 minus 4 into 7 power n minus 1 and plus 4. So minus 4 and plus 4 get cancelled. 4 into 7 power n, you can write it as 4 into 7 power n minus 1 into 7 minus 4 into 7 power n minus 1. 4 into 7 power n minus 1 can be pulled out common. So you have 4 into 7 power n minus 1 being pulled out common, and 7 minus 1 will be left inside the bracket. 7 minus 1 will be 6, and that 6 into 4 is going to make it 24. So the nth term is 24 into 7 power n minus 1. That's your nth term. To find whether this is, to check whether it is a GP or no, you can say that Tn plus 1, that is the next term, is going to be 24 into 7 power. Tn was 7 power n minus 1. I am replacing n with n plus 1 on the left hand side. So I will replace n with n plus 1 on the right hand side also. So Tn plus 1 will be 24 into 7 power n plus 1 minus 1, which is equal to 7 power n only. Now when you take a ratio of the two terms, this will be 24 into 7 power n upon 24 into 7 power n minus 1. 24 in the numerator and denominator gets cancelled, and a power m upon a power n is a power m minus n. So this becomes n minus n plus 1, which is equal to 1 only. So the ratio of any two consecutive terms is a constant. And because the ratio of any two consecutive terms is a constant, the given sequence is a GP. And for the given GP, the common ratio, that is the ratio of any two consecutive terms, that common ratio itself is equal to 7 only. Okay, so we have verified that yes, the given sequence is a GP. In addition to that, we have found the common ratio also for it, which is equal to 7. If at all you want to find the first term, it is very simple. all you need to do is put n equal to 1 in the formula for Tn, and you will have the first term also. They have not asked so much, so we have not written that much. And yeah, with that we go ahead with our 8th question. These are standard kind of questions where the solution pattern is, where the solving pattern is a standard pattern you should remember. So if you need to find the sum up to n terms, we can pull out a 2 common from this entire sequence. So that will give us 1 plus 11 plus 111 plus 111 4 times up to n terms. This will be equal to 2 by 9. I am multiplying the entire sequence and dividing it with 9. So I will have 9 plus 99 plus 999 plus 9999, and that continues up to n terms. Now whatever 9, 99 and all I have, we will write it as 9 will be written as 10 minus 1, 99 will be written as 100 minus 1, then 999 will be written as 1000 minus 1, plus 9999 will be written as 10,000 minus 1, and that keeps on continuing up to n terms. Now keep in mind that inside the bracket, how many terms did we have? We had n number of terms. So if we have n number of terms, then 10, 100, 1000, 10,000, these terms are also a total of n terms only. So we have 10 plus 100 plus 1000 plus 10,000, and that continuing up to n terms. In a similar way, we have minus 1, minus 1, minus 1, minus 1 also n times only. But minus 1, minus 1, minus 1, minus 1 n times will be equal to minus n. So that's what we finally have. And now if you check this sequence very carefully, it is a GP. If this sequence is a GP, the first term for that sequence is equal to 10. And the common ratio for that sequence, if you observe, is also equal to 10. So A is 10 and R is equal to 10. So the value for this is going to become something like this. Let's rub out this step and I'll write the final value for it over here. So this is going to be equal to 2 upon 9. The first sequence, like I said, is a GP, and sum of n terms of a GP is given by A into R power n minus 1 upon R minus 1, and minus we had an n term here. Okay, so that's the final answer for this particular sequence, or this particular sequence. So 10 minus 1 will be equal to 9. You can write it as 10 by 9 right here. Now if at all you want, you can pull out a 9 common outside the bracket and you can write it as 2 by 81. But be very careful when you do that, because there was this term minus n. So this is going to become 10 into 10 power n minus 1, minus, because you have taken a 9 outside the bracket, it was basically combination of this and this term, and then it is 9 which has gone out. So minus 9n is what you will have as the last term inside the bracket. And that's a little more simplified version of writing the final answer. Okay, so that's how you can evaluate such kind of sequences. And with that, yeah, let's go ahead with the next sum. It's a similar one, but this time the numbers that you have are in the form of decimals. So what one can do is one can pull out a 0.6, not 0.6, one can pull out a 6 common. So you will be left with 0.1 plus 0.11 plus 0.111, and that just continues up to n terms. Divided with 9. So a 9 gets multiplied inside the bracket. It makes every term 0.9, 0.99, 0.999, and that continues up to n terms. 6 by 9 will be 2 by 3. 0.9 will be written as 1 minus 0.1. 0.99 will be written as 1 minus 0.01 plus 1 minus 0.001, and that keeps on continuing, keep in mind, up to n terms. So this will be 2 by 3. 1, 1, 1. That is going to get added n number of times. That's because we had n number of terms here. And from every term, we are going to have 1 coming one time. So from n terms, if we are getting a 1 from each term, then there are n number of 1s that we have. And when we add n number of 1s with each other, we get an n. So 1 plus 1 plus 1 n times is going to give you the n here. Minus, in the second bracket, let's put this 0.1, 0.01, 0.001 and all these terms. So minus we have 0.1 plus 0.01 plus 0.001, and that keeps on continuing up to n terms. Now if you observe this sequence very carefully, again this is a GP only. For that GP, the first term is 0.1, and the common ratio for getting the next term, you are dividing it with 10. So dividing with 10 means multiplying with 0.1. So the common ratio is also equal to 0.1. Having identified the first term as 0.1 and the common ratio as 0.1, we can say that the value for this entire sequence is going to be, so we have 2 by 3 n minus the value for this entire GP. I mean the sum of all the terms of that GP will be a, which is 0.1, 1 minus r power n, that is 1 minus 0.1 power n, divided by 1 minus r, that is 1 minus 0.1. 1 minus 0.1 will be 0.9, and 0.1 upon 0.9 can be written as 1 upon 9. So yeah, that's how you can write the value for the ninth question. You can simplify this a little more like we had done in the previous question, and you can write it in this manner. Club the two terms here, so that will give you a 9 in the denominator which gets multiplied with 3, so that becomes 2 by 27. And while clubbing the two terms here, you got a 9n here, minus we got 1 minus 0.1 power n, and yeah, that's how we are answering the ninth question. And with that we go ahead with the 10th one. So here you have summation of some expression. To evaluate these kind of questions, we first split the summation, and that will give us summation of 5r square plus summation of 4r minus summation of 3. The constants can be taken out of the summation, so we have a 5 here, we have a 4 here, and 3 also can be taken out, so 3 summation 1. 5 summation r square is n plus 1 and 2n plus 1 the whole divided by 6, plus 4 times summation r will be n plus 1 divided by 2, minus 3 times summation 1 will be equal to n. So this becomes, you can pull out an n common from all these three terms. So n comes out common, and you are left with 5 into n plus 1 into 2n plus 1 divided by 6, plus it's 4 into n plus 1 divided by 2, so that can be written as 2 into n plus 1 minus 3. So if we take an LCM, the LCM is going to be 6. This becomes 12, and this becomes minus 18. Try to expand the bracket, so you have n. This will be n into 2n, which is 2n square, into 5, that will make it 10n square. Then we will have n into 1 plus 2n, so that's 3n, and that 3n into 5 will make it plus 15n. 1 into 1 will be 1, into 5 will be plus 5, plus this is going to give you 12n plus 12 minus 18 the whole divided by 6. 15n plus 12n is making it 27n, and then we have 5, 12 and minus 18, that's making it minus 1. So yeah, that's the final evaluation of the 10th question, that is, it is n, 10n square plus 27 minus 1 upon 6. If this would have been, if we would have been able to factorize it even further, we would have factorized it, but currently it is not possible. So yeah, this is going to be the final answer for the 10th question. We go ahead with the 11th one, which is a similar one. All you need to do is expand these, expand the brackets here. So this is going to give you summation of, it will be r square minus 5r plus 6, and into r makes it r cube minus 5r square plus 6r. Split the summation, so that gives you summation r cube minus summation of 5r square, but that constant, 5 is a constant, can be taken out of the summation, so it will be minus 5 times summation r square plus summation of 6r, and that can be written as 6 times summation of r. Summation of r cube becomes n into n plus 1 divided by 2 the whole square. So we will prefer to write it as n square, n plus 1 square divided by 2 square, which is equal to 4, minus 5 times summation r square is n plus 1, 2n plus 1 the whole divided by 6, plus 6 summation r is n plus 1 the whole divided by 2. So you can cancel off this 2 here and a 6 here, making it 3. And finally we can take n plus 1 common from all the brackets that we have, so that will leave us with n plus 1 divided by 4 minus 5, and 2n plus 1 upon 6 is all that we are going to be left with, plus there's a 3 that we will be having here, so we have n into n plus 1, The LCM here will be equal to 12. So this term will be 3n into n plus 1. That will make it n square plus n into 3, which is 3n square plus 3n. This will be 10 into 2n plus 1. So that will make it 20n plus 10. So minus 20n minus 10. And finally there's a plus 3. So that will become plus 3 into 12, which is equal to 36. And yeah, we can start simplifying it now. 3n minus 20n will make it minus 17n. And minus 10 plus 36 will make it plus 26. So yeah, that's the final simplification for the 11th question, and the given expression gets evaluated to n into n plus 1 into 3n square minus 17n plus 26 the whole divided by 12. Let's go ahead with question number 12. So here it is summation of r equal to 1 up to n. Now the numerator itself is a sum of squares up to r terms. So that can be, the numerator itself can be written as r into r plus 1 into 2r plus 1 the whole divided by 6, and the denominator is 2r plus 1. So 2r plus 1 gets cancelled, 6 is a constant, you can take it outside the summation, and then r plus 1 is what we are left with. So then we have summation of r plus 1 is going to be r square plus r. This will be 6 into, sorry, it's not 6, it's 1 upon 6, because that 6 came out from the denominator. So it's 1 upon 6, 1 upon 6, summation r square plus summation r. So you can split the summation also and write it like this. Summation r square is n plus 1 into 2n plus 1 the whole divided by 6, plus summation r is n plus 1 the whole divided by 2. You can pull out n plus 1 divided by 2. So this will be n plus 1 divided by 6 into 2 will be 12. And here you will be left with 2n plus 1 divided by 3 plus n plus 1 upon 2 entirely has gone out. So plus 1. So when you club the terms, this will be 2n plus 1 plus 3. That will make it 2n plus 4. And when you pull out a 2 common from here, this will become n plus 2. The 2 that you have pulled out common gets cancelled with this. So you get a 6 here. 6 into 3 makes it 18. So we have n plus 1 into n plus 2 upon 18. And yeah, that's the final evaluation of the 12th question. Moving on with the 13th one. It's a similar one. In this case, the numerator itself is a summation of all cubes. So the numerator can itself be written as r square into r plus 1 square divided by 4. And there's an r plus 1 square already existing in the denominator. So r plus 1 square gets cancelled, and this will be 1 upon 4 summation r square. So this is 1 upon 4 into n plus 1 into 2n plus 1. The whole divided by 6, that 4 into 6 is going to make it 24. So the denominator is 24, and yeah, that's how we are answering our 13th question. Moving on with the 14th one. If you check in this case, every term is a combination of two terms. The first term of each term is forming an AP, and that is 2, 4, 6 and so on. The second term is also forming an AP with the first term as 6 and the second term as 9. So in general, if I have to write an expression for the rth term, the rth term will be, the first term is an AP with the first term as 2. So 2 plus, I will say r minus 1 into the common difference, which is 2. And the second term is going to be an AP with the first term being equal to 6. So the rth term for that second AP will be 6 plus r minus 1 into the common difference for that second AP, which is equal to 3. So 6 plus r minus 1 into 3 is the second term, and a combination of the two terms here will give us the rth term for the given sequence. So the rth term is, if we expand this, we have 2r minus 2, and 2 plus 2r minus 2 makes it simply 2r multiplied by, we can write it as 6 plus 3r minus 3. So that will be 6 plus 3r minus 3. So that is going to be 3r plus 3. And yeah, that's how we can write the rth term. So the summation of all these terms, this entire sequence, is the sum of all terms which are of this type. So the given sequence can be written as S is equals to summation of TR, where R goes from 1 up to N. So this will be summation of, it's 2R into 3R plus 3. If you try to expand that, this becomes 6r square plus 6r. So this will be equal to summation of 6r square. 6 comes out, so 6 into summation r square will be n plus 1 into 2n plus 1 the whole divided by 6. That 6 gets cancelled, plus we have 6 into summation r. So 6 into n plus 1 divided by 2. That 2 and 6 get cancelled, giving you a 3 here. So you can have n plus 1 coming outside the bracket, and you will be left with 2n plus 1. Plus from here n plus 1 already has been taken out, so we are left with only a 3 here. 2n plus 1 plus 3 will be 2n plus 4. You can pull out a 2 common, so that will make it n plus 2 here, and the 2 which has come out common can be written over here. So yeah, that's how we are evaluating the 14th question, and with that we go ahead with the 15th one. Now the 15th one, if you see, every term is a combination of a total of 3 terms, where the first term is 2. The first term of every element, or the first element of every term is 2. Then for the second one it is 4. Then for the third one it is 6. So we can say that the first term is basically the nth even number. For the first term is the first even number. For the second term, the first element is the second even number. For the third term, the first element is the third even number. So if we talk of a general term, for the rth term, the first element will be the rth even number. So we can write it as 2r. Into the next term is basically the first term itself, but you are adding a 3 to it. So if you had a 4 here, you are adding a 3 to it to get 7. First term was 6, you are adding a 3 to it to get 9. So the second term for the rth term will be 2r plus 3. And for the rth term only, the third term, it's going to be obtained in a similar way. You add a 3 to 5, you get 8. You add a 3 to 7, you get 10. You add a 3 to 9, you get 12. So ultimately the last term is obtained by adding a 3 to this term. When you add a 3 to this term, you have 2r plus 3 which is 2r plus 6. And yeah, that ultimately is your rth term. The given sequence is a sum of all terms of this type. So we can write the given sequence as S, which is equal to summation of tr, where r goes from 1 up to n. So this will be summation of this entire sequence, which is 2r into 2r plus 3 into 2r plus 6. This will be equal to summation of, let's expand the two brackets here, so that will give us 2r into, it will be 4r square, then it will be 12r plus 6r, which is 18r, and in the end it will be 3 into 6, which is equal to 18. Expand the brackets again, so that will give you 8r cube plus 36r square plus 36r, and try to evaluate each of these terms. So you have 8, summation r cube will be n square into n plus 1 the whole square divided by 4. Cancel off that 4 and 8 with each other, so you are left with a 2 here. Continue with the next term, 36r square. So that will be 36 into summation r square will be n plus 1 into 2n plus 1 the whole divided by 6. That 6 gets cancelled with 36 and you get a 6 here. Plus we have 36r. So that makes it 36 into n plus 1 divided by 2. That 2 gets cancelled with 36 and you have an 18 here. Now from whatever terms you have in this expression, you can pull out n plus 1 common. So you are left with 2 into n plus 1 plus it's 6 into 2n plus 1 plus it is 18. We could have pulled out a 2 also common. So that will leave us with a 2 here, a 3 here and a 9 here. Sorry, a 2 here, a 3 here and a 9 here. Okay, so now this is going to be n square plus n. This is going to be 6n plus 3. And 3 plus 9 will be 12. N square plus this is going to be 7n. And n square plus 7n plus 12, we can factorize it and write it as n plus 3 into n plus 4. So yeah, the 15th question is getting evaluated to this expression, and this is how we are solving our 15th question. So the final answer there is 2n into n plus 1 into n plus 3 into n plus 4, and with that we continue with the 16th question. Now here if you realize every term, check the first term, it is 1 square plus 1 I mean 1 square upon 1. The second term is 1 square plus 2 square upon 2. So in general, if I try to write the rth term, in the numerator for the second term there were 2 numbers. For the third term in the numerator there were 3 numbers. In the fourth term in the numerator there will be 4 numbers. So for the rth term in the numerator there will be r numbers. And these numbers will be 1 square, 2 square and so on up to r square. Divided by denominator of the first term is 1, second term 2, third term 3, fourth term 4. So rth term, the denominator will be r only. So now you can write the rth term as, this is sum of squares of r numbers. So that will be r plus 1, 2r plus 1 the whole divided by 6. And there's an r in the denominator already. That r gets cancelled with this, and this ultimately is your rth term. The given sequence is basically a sum of all these r type of all these tr terms, and that is why the given sequence can be written as S equal to summation of tr, where r goes from 1 to n. So this will be summation from r equal to 1 to n. tr is r plus 1 into 2r plus 1 the whole divided by 6. You can pull out a 6 from the summation, and then summation of r plus 1 into 2r plus 1, that will make it 2r square plus r plus 3r plus r plus 2r, which is plus 3r, and then plus 1 into 1, which is making it 1. So this will be 1 upon 6, 2 into summation r square, that makes it 2 into n plus 1 into 2n plus 1 the whole divided by 6. That 6 gets cancelled with the 2 here, and you are going to have a 3 in the denominator plus 3 times summation r, that's 3n n plus 1 divided by 2 plus summation 1, which will be equal to n. You can pull out an n common from the terms here. So you have n by 6, and finally you can take an LCM here. LCM of 3 to 1 is going to be 6. So in the denominator you have a 6. Then you have 2 into n plus 1 into 2n plus 1. Let's expand it here only. So that's going to give you 2n square multiplied by 2 will be 4n square. Then it will be n plus 2n, which is 3n, and that into 2 will be equal to 6n. And then 1 into 1 will be 1, into 2 is going to be 2. Then you have 3n plus 3. And then you have, sorry, it's not 3n plus 3. This would be multiplied with 3. So it will be 9n plus 9. And here there is a 1. So the LCM was 6. So plus there will be a 6 here. So this is going to be n by 36. Then there is 4n square. 6n and 9n is going to make it 15n. And then it is 2, 9 and 6. That's making it 17. So yeah, n by 36 into 4n square plus 15n plus 17. That's the final evaluation for the 16th question. Let's go ahead with the 17th question. So in the 17th question, you need 12 square, 13 square, 14 square up to 20 square. We will prefer to write it as 1 square plus 2 square and so on up to 20 square. And from that we will subtract all numbers from 1 square up to 11 square. So we can write it as summation of squares from 1 to 20, and that is 20 into 21 into 2n plus 1, that will be 41, divided by 6 minus, this is sum of squares of the first 11 numbers. So that will be 11 into 12 into 23 divided by 6. So if you see, it's 2 cancels of 20 and 3 cancels of 21. So this will be 10 into 7 into 41. So 41 into 7 is going to make it 287, and this will make it 2870 minus 6 into 2 will be 12. So we have 22 into 23. That's 484 plus 22, which is 506. And yeah, let's try to subtract that. So we have 2364. And yeah, that's the final answer for the 17th question. Moving on with the 18th one. In the numerator, you have sum of sum of the first n integers. Sum of the first n natural numbers. That can be written as n into n plus 1 divided by 2. And in the denominator, we have 1 into 2 plus 2 into 3 plus 3 into 4. So you can actually write it as summation of r into r plus 1. where r goes from 1 up to n. This will be summation of r square plus r, and that can be written as summation r square plus summation r. Summation r square is n plus 1 into 2n plus 1 upon 6, and summation r is n plus 1 divided by 2. You can cancel off n plus 1 divided by 2 in the numerator and denominator. So n plus 1 by 2 gets cancelled, and you will be left with 2n plus 1 upon 3 over here, and this will be a plus 1 here. Add the terms in the denominator, so that will give you 2n plus 1 plus 3, which is 2n plus 4, and that 3 goes to the numerator, so you get 3 upon 2n plus 4 as 3 upon 22. You can cancel off a 3 here and here, pull out a 2 common from here, so this will be 2 into n plus 2. That 2 gets cancelled with this, giving you 11. So n plus 2 will be equal to 11, and n finally will be equal to 9. And yeah, that's how we are answering the 18th question. Let's go ahead with the 19th one. So here you have 50 square minus 49 square, 48 square minus 47 square, and so on up till 2 square minus 1 square. There are two methods for this. One is you can write it as a square minus b square. So it's like a plus b into a minus b. So 50 plus 49 into 50 minus 49, plus it's 48 plus 47 into 48 minus 47, and that keeps on continuing up till the last term, where the last term is 2 plus 1 into 2 minus 1. Now if you realize, the second bracket of every term is going to be equal to 1. So if the second bracket is equal to 1, the only thing that you are left with is 50 plus 49 from the first bracket, 48 plus 47 from the second bracket, and that continues up till 2 plus 1 from the last bracket. So this, if you look at it in the reverse way, it is 1 plus 2 plus so on up to 50. That is the sum of the first 50 natural numbers, and that will be 50 into 51 divided by 2. So this is 51 into 25, and 51 into 25. So that should be what, 1250 and 1275. Yeah. So 1275 is the final value for the 19th question. And the second way of solving it, the second way is a little longer method. But yeah, the way you can solve it is this. It was 50 square minus 49 square, right? So 50 square minus 49 square plus 48 square minus 47 square plus 46 square minus 45 square, and that keeps on continuing up till here you are going to have terms up till 2 square, and here you are going to have terms up till 1 square. So if you realize, the first bracket here, it's the sum of the squares of all the even numbers up to 50, and these are the sum of squares up to all odd numbers. So I'm keeping all of them in a bracket and writing a minus outside that bracket. So this is how we have rearranged our terms. We can write the first bracket as summation of 2r, the whole square. Be careful, it will be r equal to 1 to 25, not 1 to 50, because when you put r as 25, you are getting the last term, that is 50 square. From that you are subtracting 2r minus 1 the whole square, and this one also goes from r equal to 1 up to 25. So this will be summation of 4r square minus summation of 4r square minus 4r plus 1, and yeah, the limit on summation is the same. So you can pull out that summation common and simply write it as 4r square minus 4r square, minus of minus makes it plus 4r, and minus of plus 1 makes it minus 1. So 4r square getting cancelled. Summation of 4r will be 4 into n plus 1 divided by 2, but n is 25. So 25 into 26 divided by 2, and minus 1. So summation 1 will be equal to n, and n is 25. So you can cancel off 2 and 26 here, that gives you 13. And you have, okay, so it's 4 into 13, which is going to be 52, and you can pull out a 25 common. So you have 25 into 52 minus 1, which is equal to 51, and 25 into 51, that's going to be 1275. Yeah, so that's how you can find the answer by the second method. The second one was a little longer method, but a more general method that you can follow, whereas the method I discussed over here, it was a shorter method, but it was applicable only if the sum was of this type. So you may use whatever method you are comfortable with whenever a sum comes in front of you. And yeah, with that we go ahead with the 20th question. In the numerator you have a sequence of terms, which if you realize it's 1 into 3, and you need to check the first element of every term. So it's 1, 2, 3 and so on. So in the numerator the first term is always going to be equal to r, the general term of the numerator, tr for the numerator, will be written in this manner. The first term will be equal to r into the second term will be, it's 3, 5, 7. Okay, the second term is the second term of every element is forming an AP, with the first term being 3 and the second term and the common difference being 2. So the rth term will have your second element as 3 plus r minus 1 into the common difference, which is 2. So this will be 3 plus 2r minus 2, and that makes it 1 plus 2r. So r into 2r plus 1 is your general term for the numerator's sequence, and the numerator is a sum of all these type of terms. So the numerator is summation of r into 2r plus 1 from r equal to 1 to n. You can expand it and write it as 2r square plus r. And if you further evaluate this, okay, before you start evaluating it, check the denominator also. The denominator is a simple sum of all cubes. So the summation value can be written as n square, n plus 1 square divided by 4. And the expression as the value as 5 upon 9. Let's try to simplify the numerator now. So we have 2 into r square. So that will be 2n n plus 1 into 2n plus 1 divided by 6. So that 2 gets cancelled with 6, giving you a 3 here. Plus summation r will be n plus 1 divided by 2. In the denominator you will have n square n plus 1 the whole square divided by 4, and the value for this is equal to 5 upon 9. Cancel off that n plus 1 divided by 2, so you are left with a 1 here. Then there's n plus 1 getting cancelled. Okay, by 2 is not getting cancelled, so let that 1 by 2 remain the way it is. We are left with 2n plus 1 upon 3 in the numerator. N plus 1 gets cancelled, so we have n plus 1 divided by 4. Take that 4 in the numerator, so you have a 4 here, and that 4 gets multiplied with this, giving you a 2 here. And if we combine the two terms here, this will be a plus 6 here, and n plus 1 written in the denominator like this. So this is going to be 8n plus 4, and 4 and 6 is going to make it 10. The value for this is equal to 5 upon 9. Yeah, so let's try to simplify this. Take that 9 on the left, you have 72n plus 90 equal to the entire thing going on the right, so that will be 15n, 15 into n square plus n, so 15n square plus 15n, and take everything on the right, so that makes it 15n square. 72n goes here, so 15n minus 72n, that's making it 57n, and minus 90 is equal to 0. So if we try to factorize this, the factors are going to be it's 15 and 90, right? So it should be 3 and 270 is not working out well. So let's take a 5 and put it here. So 75 and 18, yeah. So 75 and 18 are the factors. So you get 15n square minus 75n plus 18n minus 90 equal to 0. So we have 15n coming common from the first bracket and plus 18 coming common from the second bracket. When you do that, the second bracket by default is going to become n minus 5. Yeah. So the value of n will either be minus 18 upon 15, which is not possible because n is going to be an integer. So the only possible value for n that you have is n equal to 5. And yeah, that's how we are answering our question number 20. Let's go ahead with number 21. For a GP, they are saying that the second term is 7. If T2 is 7, you write T2 as a into r power 2 minus 1, which is a into r power 1. And T4 is 1757, so ar cube is 1575. Okay, You can divide the two equations. So when you go for 2 divided by 1, you will have r square equals to 1575 divided by 7. So r square will be 2, then a 2 again, and 25. So r will be equal to plus or minus of 15. So I'll go ahead with the positive value of r for the moment. And when you put r as 15 in the first equation, you get a is equals to 7 upon 15. And yeah, that's how you're getting the first term for your 21st question. Moving on with the 22nd one, it's a similar one. The third term for a GP is 1 by 3. So AR square is 1 by 3. AR power 5 is 1 by 81. You can divide the two equations, that is if this is 1 and this is 2. Go for 2 divided by 1, so that's going to give you R cube. That will be 1 by 81 upon 1 by 3. It's like 1 by 81 into 3, so that makes it 1 by 27. So the value for R becomes equal to 1 upon 3. And yeah, that's all they were asking you to find. And with that, we have answered our 22nd question. The 23rd question, if you try to expand the sequence, when you put R as 1, you get 2 by 3 power 1. When you put R as 2, it is 2 by 3 the whole square. And that keeps on continuing up till the nth term, which is 2 by 3 power n. So this is a GP, and these are the sum of n terms of a GP. It is given by A, that is the first term, which is 2 by 3, into 1 minus r power n. So 1 minus 2 by 3 power n, the whole divided by 1 minus 2 by 3, which is equal to 1 by 3 in the denominator. That 1 by 3 and 3 get multiplied in the denominator. They get cancelled with each other, and you are ultimately left with 2 into 1 minus 2 by 3 power n as the final value of the given expression. Okay, so that's how we are answering the 23rd question. And with that, we go ahead with the 24th one. You have to find k so that the given numbers are consecutive terms of a GP. If these are consecutive terms of a GP, we can say that k upon k minus 1 will be equal to k plus 2 upon k. Simple. So take that k here, you get a k square, equal to take that k minus 1 here, so you get k plus 2 into k minus 1. That will be k square plus k minus 2. K square gets cancelled, and you have k minus 2 equal to 0. So k will be equal to 2, and yeah, that's the final answer for your 24th question. Going ahead with the 25th one. For a GP, the first term is 27 square, the 7th term is 8 square, so find S8. So first term means A is 27 square, and the 7th term AR power 6 is 8 square. So we write A as 27 square into R power 6. You can write 8 square as 2 cube the whole square, and this will be equal to 2 power 6. 27 square can be written as 3 cube the whole square. 3 cube the whole square is going to be 3 power 6. So we have 3 power 6 into R power 6 equal to 2 power 6. So R power 6 will be 2 by 3 the whole power 6, and that is why you can say that R will be equal to 2 by 3. Again, I am not considering the possibility of R being negative here. Actually, being very precise, we should have said R is plus minus 2 by 3, but with these questions, we are not considering the possibility of R being negative, and we are just going ahead with R being a positive number. So we are taking R as 2 by 3, and then we try to answer their question, that is find S8. So S8 will be A, which is 27 square, into 1 minus R power n, that is 1 minus 2 by 3 power 8 divided by 1 minus 2 by 3. So 1 minus 2 by 3 in the denominator is making it 1 by 3, and that 1 by 3 goes in the numerator, makes it a 3 in the numerator. And finally 1 minus 2 by 3 the whole power 8. So we can write that as 3 power 8 minus 2 power 8 divided by 3 power 8. Let's first simplify the powers of 3. This will be 3 cube the whole square, and that will make it 3 power 6. 3 power 7 is what you get here. That gets cancelled with 3 power 8, and in the denominator you are left with a 3. 2 power 8 is going to be 256. And finally we calculate the bigger number, which is 3 power 8. 3 power 4 was 81, so 3 power 8 will be 81 square. 81 square will be 62 and 6561. And yeah, that's the value for 3 power 8. In case if you do not know how to calculate the squares of numbers mentally, then I've made a video on that. It will help you to evaluate the squares of any 2-digit number, and if it's a 3-digit number up to 125, then you can calculate the square of it orally. The link for that video you can find it in the description box below. And yeah, with that we go ahead with the solution here. So 6561 minus 256. So this is going to be a 05 here, and this is going to be a 3. So it's a 6305 divided by 3. And is that divisible by 3? It's not. So yeah, 6305 upon 3 is the final answer for the 25th question. Going ahead with the 26th question. The pth, qth and rth terms of a GP are x, y, z. Find the value of the given expression. So we just go ahead with whatever they have given. The pth term is x. So the pth term is always given by a into r power p minus 1. Now because they are using an r term here for themselves, let's use capital R for our common ratio. So ar power p minus 1 is x. The qth term is y. So we can say that a r power q minus 1 will be equal to y. Similarly, a r power r minus 1 is equal to z. They are asking us x power q minus r into y power r minus p into z power p minus q. So this will be x, which is a r power p minus 1. So we have a r power p minus 1 the whole into the whole power q minus r. Y, which is a r power q minus 1 the whole power r minus p, and then it is a r power r minus 1 the whole power p minus q. So if we try to evaluate this, the power of a will be, we have a power q minus r into a power r minus p into a power p minus q. That will make it a power q minus r plus r minus p plus p minus q into capital R power p minus 1 into q minus r. If we expand the bracket, that makes it pq minus pr minus q plus r. Then we have r power q minus 1 into r minus p. It gets added to the power over here. So that will make it q minus 1 into r minus p, right? So that will be qr minus pq minus r plus p. And then finally r power r minus 1 into p minus q, and that also gets added to the power itself. So we will have plus pr minus qr minus p plus q. If you realize, all terms are getting cancelled. So q and minus q gets cancelled, minus p plus p is gone, r minus r is gone, a power 0 is left with us, which is equal to 1. So we have 1 multiplied by pq is gone with a minus pq, qr is gone with a minus qr, pr is gone with a plus pr, minus q plus r minus r plus p minus p. Everything getting cancelled, we have r power 0 again. So r power 0 makes it 1, and the final value for the given expression turns out to be equal to 1. And yeah, that's how we are answering the 26th question. Going ahead with the 27th one, you need to insert two terms between 5 and 40 so that the resultant sequence is a GP. So let the two terms be 5, 5r, 5r square and 40. So we can say that if this is a GP, T4 is 40. T4 is going to be a into r power 3. So we have a, which is 5, into r power 3, which is equal to 40. So r power 3 will be 8 and r will be equal to 2. So the two numbers that you have here are 10 and 5 into 2 square, which is 20. So the resultant sequence is a GP if the middle two numbers are 10 and 20. And yeah, that's how we are answering the 27th question. We go ahead with the 28th one. PQR are already in GP. P power 1 upon x, Q power 1 upon y and R power 1 upon z are equal to each other. So you need to verify whether x, y, z are in AP or GP or neither. So let's take P power 1 upon x equal to Q power 1 upon y equal to R power 1 upon z equals to k. So we have P. Okay, we have P power 1 upon x equal to k. Take a power x on both the sides and that will give you P as k power x. Similarly, Q will be k power y and R will be k power z. Okay, they have already said that PQR are in a GP. So if PQR are in a GP, you can say that Q upon P will be equal to R upon Q. And if you rearrange that, you have Q square equals to PR. So Q square, Q is already K power Y, the square of it. So K power Y the whole square, that will be K power 2Y. And P and R, we will write them as K power X into K power Z. So we have K power 2Y as K power X plus Z. And this tells us that 2Y will be equal to X plus Z. So if Y will be equal to X plus Z divided by 2, it tells us that X, Y, Z are all of them in an AP. So the right answer there will be X, Y, Z are in an AP. Let's continue with sum number 29. It says that if ABC are in GP and the two equations are satisfied, the two given equations have common roots, then verify that this will be equal to 0. So first of all, if ABC are in a GP, it's very clear that B upon A will be equal to C upon B, or one can say that B square will be equal to AC. Now we look at this equation and this equation. If they have both common roots, then the two equations are identical. And identical equations means it's not necessary that A and P will be equal. It's just that the ratio of A and P, the ratio of the other coefficients, those ratios are the ones that are going to be equal. So what I mean to say is A upon P, that will be equal to 2B upon 2Q. These are the coefficients of X square. These are the coefficients of X. And that will be equal to the ratio of the constants which are C by R. And let's take that entire ratio equal to K. This 2 gets cancelled. And finally, this is a relation that we have amongst the coefficients, that is amongst the terms A, P, B, Q, C and R. Now they are asking us to verify this thing. So to verify that thing, we have the left hand side written as PB square minus 2QBA plus RA square. And in this entire equation, we will prefer to write P as, we will prefer to replace PQR using this relation. So we can say that A can be written as, it's like A by P is equal to K. So we can write P as A upon K. So we prefer to write P as A upon K. So we have A upon K into B square minus, similarly we can write Q as, see B by Q is equal to K. So Q will be B upon K. So we are writing Q as B upon K, plus we can write R as C upon K. From all these terms, we can now pull out a 1 upon K common, and we will be left with AB square as our first term, minus we have 2B square A, plus we have A square C. Are these two terms the same? Yes, they are the same. So if I subtract them, this is like 2B square A, right? We can write it as 2AB square, and AB square minus 2AB square will be minus AB square. So inside the bracket, we are left with minus AB square plus AC square and plus A square C. And B square was already equal to AC because ABC were in GP. So we can write B square as AC, and this finally becomes 1 upon K, and we have A into AC minus A square C. So A into AC becomes A square C, and minus A square C is already equal to 0. And that's your right hand side. Okay. So the value of that entire expression which was there on the left hand side here ultimately turns out to be equal to 0. We have verified it, and that's how we are answering the 29th question. Going ahead with the 30th one. There are 4 terms which are in GP. We need to show that this into this is equal to this. So if PQRS are in a GP, let's call the common ratio to be capital R. So we can say that Q will be equal to P into capital R will be equal to P into capital R square, and S will be equal to P into capital R cube. And with that, we will try to evaluate whatever they have given to us on the left hand side. So on the left hand side, it is P square plus Q square, we will write it as P square R square, plus we have R square, which we will prefer to write as P square R power 4, multiplied by we have Q square, which is P square R square, plus we have R square, which will be P square R power 4, plus we have S square, which will be P square R power 6. From all these terms, in fact the first bracket, we can pull out a P square common, and we will have 1 plus R square plus R power 4. From the second bracket, we can pull out P square R square common, so that will give us P square R square, and again in the bracket we will be left with 1 plus R square plus R power 4. p square into r square, that makes it p power 4 into r square, and then this bracket is getting repeated twice, so that makes it 1 plus r square plus r power 4 the whole square, and this ultimately is your left hand side. We can mark that as equation 1, and we will now try to evaluate the right hand side, and we will see that the right hand side will also get evaluated to the same expression. So let's try evaluating RHS here. So the right hand side is PQ. So Q was already PR, and if you multiply it further with P, the first term becomes P square into R plus, so PQ became P square into R, then we have Q into R. So Q into R will be this multiplied by this, that makes it P square R power 3 plus RS. RS will be this multiplied by this, that makes it P square R power 5 and the whole square. Now from all these terms you can pull out a P square R common. So we are having P square R coming out common. Then we have 1 plus R square plus R power 4 left inside the bracket, and we have square of the entire term. Now A into B into C, the whole square, that is going to be A square into B square into C square. So we will have the square of P square, which is P power 4. Then we will have R square and the square of this entire bracket. So let's mark that as equation 2. So from 1 and 2, you can see that the right hand side is also equal to this and the left hand side is also equal to this. So ultimately your LHS and RHS both are equal to each other, which means that this entire expression is equal to this expression. Okay, so that's how we are answering the 30th question. Let's go ahead with the 31st one, which will be answered in the same manner. PQRS R in a GP. So we again write Q as P into capital R, we write R as P into capital R square, and S will be written as P into capital R cube. I hope everyone realizes that R is the common ratio of the GP. Evaluate the, okay, it's not evaluating any side, but we need to show that these are in a GP. That means we need to show that this divided by this should be this divided by this, or we can prove that the multiplication of this and this should be equal to the square of this. So we need to prove that Q power n plus R power n the whole square is equal to P power n plus Q power n the whole into R power n plus S power n. And let's try evaluating the left hand side first. So Q power n plus R power n, that will be P power n R power n plus we have P power n into R power 2n the whole square, and we can pull out P power n and R power n common, so that will give us P power n into R power n, and in the bracket we will be left with 1 plus R power n the whole power 2. So now this square attaches itself with the first term, so P power n the whole square, that is going to be P power 2n multiplied by, we will have 2 getting attached with the term here also, so that's going to make it R power 2n, and finally 1 plus R power n the whole square. And yeah, we can mark this as our equation 1 that represents our left hand side, and finally we evaluate the right hand side also. On the right hand side we have these two terms, so the first term being P power n plus Q power n will be P power n into R power n, because this was Q. R power n becomes P power n into R power 2n plus S power n becomes P power n into R power 3n. You can pull out a P power n common from here, that makes it P power n into 1 plus R power n. From here also you can pull out a P power n common, so that makes it P power n. You can further pull out R power 2n also common, so P power n into R power 2n, and then into we have 1 plus R power n left inside the bracket after you're pulling out terms common from here. Combine the terms, P power n into P power n is the square of P power n, which is P power 2n, into we already have R power 2n here, and 1 plus R power n into 1 plus R power n makes it 1 plus R power n the whole square, and mark it as 2. So from equation 1 and 2 you can see that this expression and this expression is the same. That means the left hand side and right hand side of this given equation are the same. So yeah, if the left hand side and right hand side are the same, we have proved that this is equal to this, which basically means that the three terms given in the question are in a GP. Yeah, with that we go ahead with our 32nd question, and we need to find the coefficient of x power 6 in the expansion of e power 2x by the series expansion. So we know that e power x was equal to 1 plus x upon 1 factorial, or you can just say x plus x upon 2 factorial plus, sorry, x square upon 2 factorial plus x cube upon 3 factorial plus x power 4 upon 4 factorial, and that kept on continuing. Now this is a series, or this is simply a formula that you should be knowing about e power x. If you're not aware about it, learn it now. But yeah, this is an expansion that you should be knowing, you should be having it memorized in your minds, and whenever a sum comes, you should be knowing that e power x can be expanded and written in a series format like this. Now we need the coefficient of x power 6, but in the expansion of e power 2x. So first we replace all the x terms with 2x. If you're replacing x with 2x on the left, you replace x with 2x on the right also. So here it will be 2x, here it will be the square of 2x, then it will be the cube of 2x, 2x the whole power 4, and with a power 6, the term that you will be having will be 2x power 6 the whole divided by 6 factorial. So the required coefficient is going to be 2 power 6 divided by 6 factorial. 2 power 6, that makes it 64, divided by 6 factorial is what, 720. So we can cancel off a 4 in the numerator and denominator, that should give us a 16 here. This cancels off 4 and you get 180, and you can further divide with the 4, so the numerator becomes 4 and the denominator becomes 45. And yeah, the required coefficient of x power 6 is 4 by 45. We go ahead with the 33rd and the last question in this video. The sum of infinite terms of the sequence will be what? So look at it carefully. It is an arithmetico-geometric progression, because if you check one term, it's forming an AP, and the other part is forming a GP. So with an arithmetico-geometric progression, the steps were quite simple. If I write S as 1 plus 4 by 5 plus 7 by 25 and so on, we would always multiply this entire sequence first with the common ratio of our GP. The GP is 5, 25, 125, 625 and so on. It doesn't take a genius to understand that the common ratio here is 1 upon 5. So, okay, of course for 5, 25, 125, the common ratio is 5, but they are there in the reciprocals, right? So the common ratio we will say is 1 by 5. So we multiply the entire sequence, this entire sequence with 1 by 5. So I have 1 by 5 into S on the left hand side. On the right hand side, the first term will be 1 by 5, but I'll prefer to write it below 4 by 5. Plus, second term will be 4 by 25, but I'll prefer to write it below this. I'll do the same thing with the subsequent terms. So then I will have 7 upon 125, 10 upon 625, and that keeps on continuing up to infinity. Subtract the sequences. So S minus 1 upon 5 into S will give you 4 upon 5 into S. This one tumbles down the way it is and can be written over here as 1, plus 4 by 5 minus 1 by 5 gives you 3 by 5. 7 minus 4 gives you 3 upon 25, plus 10 minus 7 gives you 3 upon 125. Subtract the two terms here, you get 3 upon 625 and so on. Now this continues up to infinity. You can pull out a 3 common from all the terms in this sequence, and when you do that, the numerator for each of them is going to be equal to 1. So into 3 is what we have. The value for this is now 1, plus, if you realize this is an infinite GP, and for an infinite GP the sum up to infinite terms is given by A, that is your first term, which is 1 by 5, divided by A minus R, divided by 1 minus R. So 1 minus the common ratio, which is again equal to 1 by 5, and the whole thing is getting multiplied with a 3. So this becomes equal to 1 plus, this is going to be 4 upon 5, 1 by 5 upon 4 by 5 makes it 1 by 4, and that multiplied by 3 makes it 3 by 4. So this is going to be equal to 7 by 4, and that is the value of 4 by 5s. So we have 4s by 5 is equals to, we just got 7 by 4. You can take that 5 and 4 on the other side, and s will now become equal to 35 upon 16. And yeah, that's the sum of infinite terms of this sequence. And yeah, that's how we are solving the 33rd question. With this, I am done with whatever contents I wanted to cover in this video. I hope that the contents have been someplace somewhere helpful to you in your preparations. Thank you for watching.